Hi guys, I hope you're all well. So I am doing a recording covering the last part of Learning Unit 4, which is, again, as I said, pretty much the same calculations that we had gone through in Learning Unit 3. So we went through for your grouped data so far. We went through your mean, median, and mode calculations, and we also looked at your skewness. So the next thing we're looking at are your measures of dispersion, which are your calculations like your range, your standard deviation, your coefficient of variation, your Q1, your Q3, your variance, and so on. So the first of those that we're looking at are your quartile calculations, and you'll see that they're calculated in almost the exact same way as your median calculation. So it's very similar to the median calculation. And how it's calculated is firstly Q1, same exact steps that we had followed when it came to your median. First step is to determine the position of the median. And the position of Q1 is calculated as n over 4, or you can say 0.25 times n. It will both give you the exact same answer. So once you know the position, you'll find the interval within which your quartile will lie. And then the third step is to actually calculate the quartile using this formula. So the formula says, remember L1 stands for your lower limit or your lower boundary of your interval. So if the interval is, let's say, 20 till 29, 20 is your L1, it's your lower limit. So L1 plus, and then in brackets you have a numerator that says n over 4, which is the position, minus the sum of the frequencies in the groups before the group you selected. And then your denominator, you have the frequency of the group you selected. And on the outside, you have C, which is your interval width. So again, we're pretty much using the exact same idea as with your median. 3 steps, position, interval, and then calculating using the relevant formula. So I am going to do an example in a minute, but I just want to take you through the formula first of the upper quartile or the third quartile. So exact same 3 steps, position first. Here the position is calculated as 3n. Sorry, trying to do that 3 there. So it's calculated as 3n over 4. And as you can see, the difference between this and ungrouped data, is there's no 1 added. Remember, with ungrouped data, when we were calculating the position, we said n plus 1 over 4, or 3n plus 1 over 4. Here we're ignoring the plus 1 portion, and then it's 3n over 4, your position, you'll find your interval that you're using, and then the formula, again, pretty much identical to the one at the top. It is L1, your lower limit, plus 3n over 4, which is the same value that you had determined in determining your position, minus the sum of the frequencies in the groups before the group you selected over the frequency of the group you selected, and it's multiplied by C, which is your interval width, or your interval size. Okay, so this is the calculations involved when you are determining your Q1 and your Q3. And let's look at this example then to calculate both of those. So I'm going to stay on this slide and work with the values for you, because I obviously need the information to show you how to work it out here, but you will find that the solutions are on the next slide. Okay, so the first one is your Q1. Remember, we said that the formula we use when calculating it is Q1 is equal to your lower limit plus. Then you have a bracket with a numerator that says n over 4 minus the sum of the frequencies in the groups before the group you selected over the frequency of the group you selected multiplied by C. So this is your formula for it. Step 1 then is to determine the position. The position is calculated as n over 4. And here is the sum of your frequencies, which is 30. So 30 divided by 4 gives you 7.5. So the 7.5th value basically in your data set is your Q1. Then you're going to determine which interval 7.5th value lies within. So you look at your frequency column for this. You can also look at your cumulative frequency, as I mentioned in the previous session, if you have the column. So basically, your frequency column is saying to you, so far in the first interval, there are 3 values. You need the 7.5th value, so it's definitely not the first one. Then when you say 3 plus the next frequency, which is 5, so 3 plus 5 gives you 8. This says to you that when you added on this next frequency, this is where you found your 7.5 value. So your interval then is 20 till less than 30. Now we can work with the formula, which says your lower limit, which is the 20, plus, sorry, Q1 is equal to 20 plus. Within brackets, you have at the top n over 4. N over 4 is what you calculated in the position. So you can either write down again 30 over 4, or you can just write down 7.5, whichever you prefer. So n over 4 minus the sum of the frequencies in the group before the group you selected. So you selected this group, you're summing up the frequencies before it. Now here there was only one group and one frequency before it. So that was 3, but if there were numerous groups or intervals before this, you'd sum them all up. So there was only one, and that was minus 3 now. And then in your denominator, you have the frequency of the group itself. So the group you selected was 20 to 30. The frequency of that group is 5. And then on the outside, you have your value of C, which is your interval width. Your interval width is looking at your interval. So any one of them will have the same interval width. They can't have different widths for each of these intervals. So 20 till less than 30 technically means 20 up until 29, including 20, including 29. So you're going to count, because it's easy to just say 29 minus 20, which gives you a C value of 9. But it's including 20 and 29. So you need to, and this is why I stressed in the previous session, you need to physically count on your fingers. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. That gives you a C value of 10, since it's including both the value of 20 and the 29. So now you have all of the values that are going to your formula, and so your Q1 is 29 minutes. Okay, so this is Q1. Then you have your Q3, which is again same idea. The formula though is L1 plus. At the top you have 3n over 4 minus the sum of the frequencies in the groups before you selected over the frequency of the group itself, and then it's multiplied by C. So first step is to determine the position, which is 3n is 3 multiplied by 30 over 4 gives you a position of 22.5. So you're looking for the 22.5 value. Again, if you are looking at your cumulative frequency column, or you're going to look for where did you find between which two frequencies, cumulative frequencies, did you find that it changed such that 22.5 was accommodated. So if you look at this cumulative frequency column, it's saying to you so far there's 3 values. Then it's saying to you that so far in the first 2 categories, it is 8 values so far. Then 17 is saying to you in the first 3 categories, there are 17 values. But again, you're looking for the 22.5th value. Then 24 is saying to you that so far in the categories we've looked at, there are 24 values. So when we moved from 17 to 24, this interval was where we added on and then got the 22.5th value. Your interval then is 40 up until 49, including 40 and 49. So then in your formula, you have your lower limit, which is the 40, plus, then within brackets, you have at the top 3n over 4, which is the 22.5. So you can again also just write 22.5 minus the sum of the frequencies in the groups before the group you selected. So basically the 3, the 5, and the 9. Added up gives you 17. And then you have in your denominator the frequency of the group itself. So of the group you selected, its frequency is 7. And your C value would have to be the same. It is 10 because it's 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So you have everything that goes into calculating the Q3. And as you'll see, your Q3 is 47.86 minutes. Okay, so Q1 was 29 minutes from the previous page, or slide, sorry, and Q3 is 47.86 minutes. And then you'll see that on one of the next slides, but while we're working on this, I would like to go through it. But on one of the next slides, you'll see how to calculate your interquartile range. It's exactly the same as we did in Learning Unit 3. It's calculated as Q3 minus Q1. So again, even though it is on one of the next slides, I would like to work through it here just so that while we're on this and you have the values, you'll know how to calculate it. So 47.86 is your Q3 minus your Q1 is 29, and that gives you an interquartile range of 18.86 minutes. And then your quartile deviation is calculated as your interquartile range divided by 2. So here, your interquartile range is this 18.86. So it's going to be the 18.86 divided by 2, which is 9.43. Okay, so that's your interquartile range and your quartile deviation. And then the next thing we're looking at is how to calculate, how to calculate your variance. So this is the formula that we'll use when it comes to your variance for your grouped data. So the formula, I'd like to just take you through the formula and then we'll look at your standard deviation and then we'll do an example. So it says that your variance is calculated as the sum of each frequency multiplied by its respective value minus the mean squared over the sum of the frequencies minus 1. So obviously at this point, without trying it on an example, it will be a bit vague, but you'll see when I'm going through an example with you that it is pretty straightforward in terms of the calculation. It's just that you obviously need to understand what is being multiplied by what and so on. So it is, as I said, the frequency. So just ignore the sum of for now. It's the frequency multiplied by its respective midpoint. So this is each frequency multiplied by its respective midpoint. And I'll show you what we mean by the respective portion just now. Minus the mean squared. And then it's over the sum of f minus n. The sum of f is also known as your n value, your sample size, and then it's minus 1. So this is the formula for your variance. I'll take you through the calculation just now. And then your standard deviation is literally the square root of this. Remember, the standard deviation is always the square root of variance. So it's a square root of this whole formula of the sum of each frequency multiplied by its respective midpoint minus the mean, and that is squared, and then it's over the sum of f minus 1. So that's your variance and your standard deviation. And then the other calculations we'll be going through is your range. I'll show you how to calculate it again in a second using an example. But your range is calculated as the upper boundary of the highest class minus the lower boundary of the lowest class. So that's the formula for it. But again, I'll show it to you. And then your coefficient of variation, it's the exact same formula as with your ungrouped data. It's your standard deviation over the mean multiplied by 100. It's expressed as a percentage always. We did the interquartile range and we did the quartile deviation as well. Okay, so this is the table that we're going to be requiring. So this is using the example that we used in the previous session, if you recall, where we calculated the mean, the median, the mode. So we're using the same example because the values from there were already given to us. We calculated the midpoints and so on. So firstly, one important thing just to reiterate, in case you have forgotten, your midpoint, it's denoted by the symbol X, as you can see here. It's calculated as, so you have a different midpoint, for each interval. So for the first interval, it's 10 till 20. The midpoint is calculated as 10 plus the 20 divided by 2. That gave you the 15. The next one was 20 plus 30 divided by 2. So you basically just take the lower limit plus the upper limit divided by 2. And then the next was 30 plus 40 divided by 2 gave you the 35. 40 plus 50 divided by 2 gave you the 45, and so on. So this is how you got to the midpoint, which is also called a bin mark. And then you have your frequencies given to you. Oh, sorry about that. You have your frequencies that are given to you. And then your mean, which we calculated in the previous session. Remember, your mean is each frequency multiplied by its respective midpoint. And then that gave you the 0, 6 times the 25 gave you the 150, 10 times the 35, 18 times the 45, and so on. Once you had this, you added all of them up. It gave you the total of 2,210, and you divide that by the sum of your frequencies. So divide 50, and that's how you got to your mean of 44.2. Okay, so this is the table that we'll need to calculate the range, the variance, the standard deviation. And then your coefficient of variation would obviously be based on those values. Okay, so first thing we're looking at is your range calculation. Your range is calculated as the upper value in your the upper boundary in your highest limit. So if you look at your different intervals, the last interval, the upper limit of it, which is 70, minus the first interval that you had, which is this, the lower limit of it. So minus the 10. So that gives you a range of 60. So basically the last limit here minus first limit at the top here. So that's your range, as simple as that. Now let's look at your variance calculations. So remember we said that your variance was calculated as, sorry, I just want to change this. Okay, so your variance was calculated as the sum of each frequency multiplied by the mid minus the mean squared over the sum of f, or your sum of your frequencies minus 1. So here, these are your midpoints, these are your frequencies, your mean is 44.2. So I'm going to write out the formula here for you and show you how we calculate it. So your VAR, your variance, is calculated as, so your denominator is the sum of f minus 1. The sum of f is 50, or the sum of your frequencies. So we know your denominator is saying 50 minus 1. Now in your numerator, again, just ignore the sum of sign for now. It says take each frequency, so the first frequency is 0, multiplied by its respective midpoint. So its respective midpoint would be the one in line with it, which is 15, minus the mean, which is 44.2, and squared. Now this is where the sum comes in. This means that you're going to add on the exact same idea, but for the next interval. So for the next interval, basically we did the first one. For the next interval, the frequency is 6, its respective midpoint is 25, minus the mean of 44.2 kgs squared, plus, now again, the next one. The frequency is 10, the midpoint is 35, minus the mean of 44.2 squared, plus the next one. The frequency is 18. The midpoint is 45 minus the mean of 44.2 squared. And then I'll just write it at the top here because I don't have much space. The next one is 14. Midpoint, frequency. Midpoint is 55 minus the mean of 44.2 squared. And then the last one, the frequency is 2 multiplied by 65 is the midpoint minus the mean of 44.2 squared. So now you've taken care of every value here. And you have your numerator, you know your denominator says 50 minus 1. And so here, it's just a matter of calculating it. So as you can see on the next slide, exactly as I had shown to you, the whole working out is here. And that gives you 113.63. And then your standard deviation is just the square root of that 113.63, which as you can see here is 10.7. Okay, so that's your standard deviation and your variance calculations. Then your coefficient of variation, it's calculated as your standard deviation over the mean multiplied by 100. So your standard deviation is 10.7, your mean is 44.2, multiplied by 100 gives you 24.18 as your coefficient of variation. Okay, so that's your range, variance, standard deviation, and so on. Your interquartile range, this I showed to you, but the answers here are based on this table. That, the one I went through with you was based on the other example. Okay, so your interquartile range, and then as I said, your quartile deviation, it's interquartile range divided by 2. And then the next thing we're looking at, and the last part of this learning unit, is your percentile calculation. So your percentiles is, I'm going to explain to you how to calculate it for your group data and your ungrouped data. I'll take you through it with your ungrouped data first. I didn't go through an example with you covering your ungrouped data. So I'll go through an example of that first, and then I will go through how to calculate it here with your grouped data. So let me just explain to you for a second what a percentile is. So if you recall, we said that a median is where we split your data set into 2 equal parts. A quartile, so a median, is where we split your data set up into 2 equal parts. A quartile was where we split up your data set into 4 equal parts. A percentile, literally from the word percentage, is where we split up your data set into 100 equal parts. So we can ask you to calculate any percentile ranging from 1 to 100. So for instance, like here, they're saying to you calculate the 30th percentile or the 80th percentile, for example. So when it comes to, and this is extremely important, when it comes to calculating your percentile, it follows the same 3 steps as with your median and your quartiles, where the first step is to, so and I'm working with ungrouped data here. So the first step when it comes to your ungrouper is to rearrange your values in ascending order. So from smallest to largest. Then you will determine the position of the quartile, of the percentile. And the position of a percentile is calculated under your ungrouped data. It's calculated as P multiplied by N plus 1. And then the third step is to actually calculate the percentile. Okay, so let me give you an example of a percentile. Let's suppose that we had values 4, 7, 10, 13. So similar values from one of the examples we previously went through. Let's see, 18, 21, and 28. Okay, so let's suppose we had these values. There are 3, 6, 7, 8 values in total. Okay. Is equal to 8, which I'll write here on the top. N is equal to 8 since there are 8 values in total. So as it stands here, I have listed them such that they are in ascending order. They have been listed from smallest to largest. Okay, so you don't need to do that step here, but obviously in a data set where the values are just arranged anyhow, you would need to arrange it from smallest to largest. Second step is to determine the position. So let's suppose a question said to you, calculate the 40th percentile. Let's use this wording here. So they said you calculate the 30th percentile. How we'd calculate the position is we would take, they're saying the 40th percentile. So we convert 40 into a decimal. So it will be, oh, sorry about that. We would make it a decimal of, remember 40 as a decimal is 40 over 100, which would be 0.4. So your position would be 0.4 multiplied by n, as you can see here, plus 1. N is 8 plus 1. So it's basically 9 times 0.4. So this gives you a position of 3.6. What this is then saying to you is take, and you'll see it's very similar to your quartiles. It's saying to you, take the third value. So the number 3 indicates take the third value in the data set, which here is the number 10. So 10 plus, you work out the difference between the number 10 and the number after it, which is the number 13. So 13 minus 10. And multiply that by just the decimal remaining portion here, which is 0.6 or 0.6. So basically, again, here you're taking the third value and you're multiplying it by, you're taking the third value and you're adding it to the difference between the value after that minus that value itself. So basically, this is the fourth value minus the third value, and then it's multiplied by the decimal that was remaining from the position. So this gives you an answer of 11.6. Sorry, 11.8. Okay, so this would be 11.8 would be your 40th percentile. Okay, so this is under ungrouped data, which is fairly straightforward because it is the same as your quartiles calculation under ungrouped data as well. Same idea is applied. Then you have, when it comes to your grouped data now, so the one we're working with now. So again, when it comes to your percentiles, it follows the same steps as your median and quartiles, where the first step is to determine the position of the percentile. The position is calculated as P times N. There's no plus 1 here. Once you have the position, you determine the interval within which your percentile will lie. And once you have the interval, you will need to look at the formula on the next page. So here is the formula for your percentile. So it's calculated as, so it does look a bit complicated, but you'll see as I take you through the calculation that it's actually not too bad at all. So the formula says LP, which is the same as L1, it's your lower limit of your interval. Then it says in your bracket, you have a numerator which says upper limit, so UP stands for upper limit, minus the lower limit of the interval. So again, if the interval says 20 to 29, for example, 20 is your upper limit, or UP. It should say UL though, but this is how it appears in your formula sheet. So your upper limit, so I'll just say upper. Sorry, not your upper. That's your lower limit. So let's say 20 to 29. 20 is your lower limit. 29 is your upper limit. So basically in this part, it would say 29 minus 20. Your LP would be your lower limit, which is 20. Then it says P over 100 multiplied by N, which is, let's say that they asked you for the 40th percent, for example. P over N is, P over 100 times N is 40 over 100 times the sample size. And then it's minus the sum of the frequencies in the group before the groups you select. Minus the sum of the frequencies in the groups before the group you selected. And then this is over the frequency of the group itself. So let's look at an example. So on the next slide, I'm going to work with this. This is an additional example, but I'll work with question 8 here, which asks you for the 48th percentile. So remember, first step is to determine the position, which is P times N. Second step is to determine which interval you are working with. And then the third step is to use the formula, which says lower limit plus, then you have upper limit minus the lower limit multiplied by P over 100 times N minus the sum of the frequencies in the groups before the group you selected over the frequency of the group you selected. And that's your formula. So let's look at the first part of it, which says that you will determine the position. So your position is then calculated as P times N. So your P, wait, can I write this here? I'll do step 1 here. So P times N. P is 48, which will convert to a decimal, so 0.48 times N. Your N is the sum of your frequencies, so the 2 plus the 7, basically the sum of all of these. So 2 plus 7, 9, 10, 18, and 12 gives you a sum of your frequencies of 30. So 0.48 times 30. So this gives you a position of 14.4. So you're looking for the 14.4th value. So here, once you know the value or the position you're looking for, you're going to look at, remember, your frequencies. 2 so far is telling you that so far in the first interval, there are 2 values. Then you're going to add on the 7, telling you that so far in the first 2 intervals, there are 9 values. So definitely not the first 2 intervals. Then when you add on the 1, it's saying to you so far there are 10 values. Again, not the next interval. Then when you add on the next frequency, it says to you 10 plus 8 is so far 18 values. So when you add the next one, the interval that you found your percentile in was 25 to 29. So this is the interval you're working with. Now, in terms of the formula, so we know the interval is 25 to 29. So I'm just going to clear the screen so that we have some place to work. So 25 to 29 is your interval, and your position in the first point step was 14.4th value. Okay, so then you have, and I'll just write out the formula for you here again. It is calculated as your lower limit plus, so upper limit minus your lower limit multiplied by P over 100 times N minus the sum of the frequencies in the groups before the group you selected over the frequency of the group itself. So your lower limit, so the group is 25 to 29, lower limit is 25 plus, within your brackets, the first part says your upper limit, which is 29, minus your lower limit of 25. Then it's times your P over 100. So P is 48 over 100 times N, which is 30, minus the sum of the frequencies in the group before the groups you selected. So you selected 25 to 29. This was its frequency. Now you're going to sum up the frequencies of the groups before it. So 2 plus 7 plus 1 gives you 10. Sorry about that, it's a bit squashed up. And then in your denominator is the frequency of the group itself. So it's over 8. So now you have your values that go into it. Let me write that out a bit more neatly for you. So 25. Sorry, let me clear the screen and write it out neatly. 25 is your lower limit plus the first part of it says 29 minus the 25. Then you have here 48 over 100 times your sample size of 30 minus the sum of the frequencies in the groups before that is 10. The frequency of the group is 8. So this gives you, and let me calculate the answer for you. Okay, so this gives you a final answer of 27.2. Okay, so this is how you calculate your percentile. Please try out the examples on the slide and the one I had gone through in the previous section, and you now will be able to answer all of your questions in your assignment. If you guys have any questions, please let me know. And for now, stay safe, and we will have our next collab session next week. Cheers, guys.